Okay.
All right. So we get that individual assignment due at the end of the week. It's going to be really similar to what we did in Excel for the normal distribution as well as like the log normal. Then that connect homework and start chipping away at that. I think we probably covered about half of the questions. The other half we'll probably get through this week. You can make a pretty good chunk, take a pretty good chunk out of that based on what we've already done. Other than that, it's kind of where we're at. The housekeeping stuff. Any questions?
Yeah. Are you required to go to dialogue days?
Yeah, so I'm not canceling class for dialogue days, and I'm not expecting you to go to any. I know that some professors give extra credit or are ready to go. I think that's good. I think they're really useful. If I would look at, so this would be my recommendation, look at the sessions, and I would at least go to one that you think you could be interested in that subject relative to your career. Because the best thing about dialogue days, in my opinion, being very honest, is being able to network with people. They say some great things during the presentations, and they can be very useful and very interesting. But the real valuable thing is a lot of these people who are giving this speech or kind of talking are alumni who are coming back. They're coming back for a reason. Most of them like interacting with students. They probably have possible internship opportunities with the company they work with, and getting kind of connected with them, even if it's not this semester, just exchanging an email or something like that goes a long way. I've seen it happen for a couple of people through dialogue days. I work with the ECON advisory board, so we have a lot of people come back for those. So I'm not saying, don't go to any of them. I think I would choose a couple, and if they really think that those are pretty line up with your interests, especially relative to your career, I would try to go to those and then talk to the people afterwards. I know it's not fun. I know it's kind of hard to do, but that is really the most valuable thing you will get out of dialogue days if other professors are expecting you to go. Does that answer the question? Probably more than answers the question, right? Any other questions before we get going here? Okay. So today should be, I don't know, a little bit easier. I know that Friday, the log normal stuff, all that's very technical. It's a lot. We'll take a little bit of a step back here. And I think this is more of a conceptual thing, what we think about today. And then we'll probably start going back into the technical stuff by the end of class, so we can kind of pick up at that on Wednesday. So up to this point, I've told you about normal distributions, uniform, exponential, log normal. All of these, I was using the notation that the standard deviation was this, right? So essentially, I didn't really say this explicitly, but we were talking about population distributions, okay? So usually we don't have population data. We talked about this earlier in the semester. Usually all we have is a sample. So our goal is to get a sample that is reflective of the population. If I'm interested in something like average human height, and I only include people in my sample who play on a collegiate basketball team, is that going to be a good sample about the population? No, they're on average going to be taller, right, than any random person I select from the population. So what we want to try to do is random sample, right? We don't want to over-select from certain groups. So we're going to try to random sample. We've got two situations, which is a finite and infinite population. I'm not going to spend too much time on this because almost everything we deal with is a finite population. Even if it's the population of the world, there is a limit, right? There is I don't know what it's up to, close to 7 billion now or something like that, right? But there is a limit on the number of people. Infinite populations, very rare. We wouldn't be dealing with these. This would have to be something like a computer-generated process where it's just going forever, right? But they don't present a whole lot of additional challenges, and we're really not going to focus on those too much. But those are the two that we have. I think mentioned earlier in the semester, we love population data. The censuses are very not feasible. It's also really hard to get accurate information, just kind of asking survey questions. And so generally, we're stuck with a sample. We'll then use that sample to make inferences about the population. But those inferences will be incorrect if our sample isn't representative of the population. So how can we kind of ensure this? So we've got some finite sample. We'll call that capital N. Right? That's the population, number in the population. We already used this when we were talking about the means and the variance. Lowercase n is going to be the size of our sample. So lowercase n has to be less than capital N, right? Our sample is a subset of the population. So we can do this two ways, with or without replacement. And there's advantages, I guess, and disadvantages of both. For the most part, 90+% of the time, I would probably put it closer to 99%, one of these is going to be better. Right? So if you think about I'm randomly sampling, let's say, even if I just wanted to do it with students in this class, right? You're the population, and I'm going to take like a 5-person sample. So I put all your names in a hat, I draw a name out, maybe I'm recording, I don't know. Maybe I'm recording height. So I'm going to write that, whoever I put out first, I record their height, put the name back in the hat, shuffle around, draw another name. That would be with replacement, right? Even after I select one observation, it's potentially possible with replacement for me to then select it again, especially if my population is small. Like if you guys were my population, right, there's only 14, I mean, it might be fairly likely I get the same person twice in a pool of 5 names. Without replacement is that once I pulled someone's name, it never goes back in the hat, right? They're only going to end up in my data set one time, maximum. They can never end up in it twice, right? Never, if I'm doing without replacement. So which of these do you think is probably preferred? Yeah, I saw someone mother, right? Without replacement. Because what happens if I get the same name twice? Remember when we were talking about the mean? And we said you can kind of think about it as each observation was being like equally weighted. Well, if I get someone's name twice, then one of my observations could be weighted twice as much. And why? Why does that person, I mean, I'm acting like the data set we have with people, but why would that person, why should they be weighted more? They should, more often than not. Maybe there's something where if like you've got group data with replacement would be okay because one company would actually represent a certain number of stores, but it's very rare that that's just going to be a situation. Okay. So generally we'll do without replacement. And I say here it's better. Someone would probably argue, there is some situation where it's not, but for 99% of the time, it's going to be better. Okay. I'm not going to worry about infinite populations because we're not going to deal with that. But basically, you still want the same idea. You still want to get some random sample. Okay. Just here, you got to make sure that you're selecting things that they're not dependent on each other. But like I said, we're not really going to be dealing with infinite population. So we'll move to the next idea, which is how do I maybe guarantee, even with random sampling, that my sample is going to look like my population? Okay. So let's think about a scenario where I'm interested in, I don't know, the average income in the US, and I know there's a gender disparity. I know there's just wage gap disparity. And so if I get a sample of 100 people, right, so I want my sample size to be, a marker that works. I want my sample size to be 100. Right? If I want my sample size to be 100, if I randomly sample, what's the most common outcome of the number of males I would have in that sample? About 50-50, right? If you look at the general population, it's about a 50-50 split. So on average, I will get a 50-50 split. But there is a chance, like when we're thinking about like that binomial, there's a chance that I get 60-40, right? Well, if I get 60-40 and I know there's a wage gap that exists, well, then my sample isn't going to match up with the overall population because I know the population's 50-50, right? Or I'm simplifying, obviously, the idea of gender. And I get that. But like the idea that like it's the vast majority is about a 50-50 split, right? So what I might want to do is I know I have these two groups and I know I want my sample to match that population demographic. So maybe what I do is I randomly sample 50 males. I randomly sample 50 females. I then combine those to get that total sample that I wanted of 100, right? That way I've still randomly sampled in terms of I've randomly sampled males and randomly sampled females, but by selecting from both groups, I've guaranteed that my sample will match up with the population, right? I could do this with things like race, right? Like I want to make sure that my sample matches like the demographics of the United States in terms of race. Or maybe I want to make sure that every income group is accurately represented. And so I make sure that I'm randomly sampling, I don't know, 5 people from the $0 to $20,000 category, 5 from the 20 to 40, so on and so forth, right? And then I throw them all together. So the idea of stratified random sampling is I divide the population into these subgroups, right? And what has to be true is that there's no overlap. So like the idea of I can create income brackets, kind of ethnicity identifiers, or maybe gender identifiers, that I can't have people belonging to both groups. Because if I had observations being part of multiple groups, what could happen? I could accidentally select the same person, but in both groups. So that has to be one thing that we make sure when we're doing the stratified random sampling. We'll then randomly select from each stratum, or each group is an easier way to say that. And then we'll kind of combine those to get our full sample. So nothing, it's not too crazy. It's just a way that we can guarantee our sample matches up with certain characteristics to our population. Now, what characteristics do I probably want to stratify off? And my example of like the pay gap and then making sure I have equal gender, why did I do that? I stratified by gender because I know that's going to influence the variable that I was interested in, which was income. Right? It makes no sense to stratify off of, what's one? Eye color if I'm worried about income, right? At least I've never seen a study that says eye color is correlated with income. Maybe someone has done it, but some trait that is unrelated to income, it would make no sense to stratify by, right? So it really only makes sense when you've got a characteristic that you know is going to influence that variable you're interested in. Okay. What else do I want to say here? Yeah, it's kind of appropriate when I want to make sure if I've got multiple groups within my population that I have them accurately represented in the sample. And then this is kind of the idea that I'm only going to stratify off variables that are related to the variable that I'm interested in. So we'll see this done a lot with age, gender, income. What's the other one I mentioned earlier? Oh, ethnicity. You'll see kind of making sure you have a demographic breakdown that looks like the US as a whole. Okay. So let's think about something very similar, but a little bit different, right? So it's called something different, but it's the same idea. So if we want cluster random sampling, right? This is where I'm going to randomly sample not from a group, with these different groups by characteristic, but I want to randomly sample from subgroups, right? So these subgroups aren't necessarily like all male or all people over 60 or all people within this income. It's just going to be, I've got this subgroup that is kind of like a miniature version of the population as a whole. I'm going to randomly sample from that little subgroup. And I've got another little subgroup from the population. I'm going to randomly sample from that subgroup. But I'm not differentiating these by characteristic. They're just kind of smaller representations of the population. So the majority of time where we'll see cluster random sampling is going to be probably geographic, right? So the real application of this, I'm going to, put these up here real quick and then I'll kind of talk about this a little bit more of a context that makes sense. So you can think about this as, let's say I wanted 100 people in my sample, okay? But I want to make sure that that sample kind of matches up with the dispersion of population in the US, right? So I know that there's way more people in the US from California than there is from Delaware, right? So what I might want to do, and I can think about California and Delaware, right, are really just subgroups of my population, right? I guess if you want to get technical, I am differentiating off the characteristics of geography, but within those states, I still see people who are over under 60. I still see people of both genders, every single race, like all these different things. So I've not stratified this by any characteristic of the data. I'm just looking at these smaller versions of the population. Okay? But I know that of these 100, maybe I want to make sure that 15 of them come from California, kind of reflecting the fact that, California makes up a pretty good chunk of the United States. And maybe I only want to get 2 people from Delaware, probably, actually, if I'm being accurate here, I probably only want 1, right, to match up with the population. Maybe if I'm doing something like, I'll look at Indiana, maybe I get 3 people from Indiana. I'll then go through every single state so that whatever the numbers I randomly sample from the states kind of match up with the breakdown I see for the overall population in the US. Then I'll combine them all to get my final sample of 100 people. And now I know this final sample of 100 people kind of accurately reflects the percent of the population that is from each state.
Kind of like the House of Representatives.
Yeah, if you want to think about this like the way that we do the House of Representatives, exactly like that, right? Now, I mean, we're not randomly sampling politicians, but like the idea would be, right, like if I would basically want to create a sample, probably not 100 people. This shows my lack of political knowledge. I forget what 400 and something, right? Representatives. So you would want to have kind of however many representatives you have from each state, and then kind of combine those all together. But yeah, it's really, it would be exactly like that. Yeah. Are there questions on this? Keep moving. I don't think I have anything else to say there. Yeah. So a really good example of this, where we see this being used, and we'll start probably not till Friday talking about proportions, but whenever we're trying to predict the outcome of elections, these polls, at least what they should be doing, is trying to do some type of cluster random sampling, right? Because you know that the number of votes from different parts of the country, you're going to have way more coming from California than you are from Indiana, right? And so even if I'm doing this within state, right, and I don't want to worry about the fact that, you know, there's just no electoral, but maybe I just want to know what's the outcome in Indiana. Well, I should probably oversample. Is it Hamilton County? It's in like around Indianapolis. It's okay. I didn't grow up in Indiana, but I've been here for a while. So, right, I probably want to sample more people from Hamilton County than I do from, I don't know, some desolate. What's the one that's just north of Muncie? Huh? Hancock County would be going, right? So I want to make sure that if I'm building these polls, I divide it up into these different counties, randomly sample from the counties, but make sure I'm sampling more people from the counties that have a higher population, fewer people from the counties that don't. Then I'll throw them all together to get my final sample. And then from that sample, I'll hopefully have a more accurate representation of what's going to happen in the upcoming election. Maybe I'm thinking about like governor or something like that. Any questions on this? I could even get like real tricky with it. Like maybe I want to make sure that I randomly sample cluster sampling because I know the population differences across the county. But what's probably also very different across some of these counties, age demographics, race demographics, which I know, you know, on average, right, we might see differences in the way that those groups vote. And so maybe I do cluster random sampling, and then within cluster random sampling, like I'm only sampling this many people from Hamilton County, I make sure that, you know, 5 of them are over 60 and 20 of them are under 60 or something like that, right? So I can kind of combine both of these to make sure that I'm getting a really accurate representation of my population with my sample. All right, so it's not feasible usually to get population data. We've got some tricks that we can kind of get to, you know, not guarantee, but be more likely to have a sample that reflects my population. It's still very possible if I'm randomly selecting, right? Even if I think about kind of the breakdown of men and women, maybe I accidentally over-selected female CEOs and over-selected male, I don't know, janitorial staff, right? Well, that's going to create a problem. It's just the luck of the draw, right? So what could go wrong with, even if I employ all these methods, and let's say I just happen to get this pretty accurate sample, or at least I think it is, what could go wrong? So a really good example of this, I'll try to go through a couple of political examples today because I think it's easy to think about some of these biases that might exist in our samples. And when I say bias, kind of that all I'm referring to there is that our sample isn't matching up with our population. It's biased in some direction, okay? So this would be the idea, like if I oversampled males, then if I'm looking at height, I might be a little bit biased towards finding a higher on average height. So if you go back, 1936 election, FDR won, so we kind of already know the outcome based off of history. But the guy that ran against him was Alf Landon, which I don't know how that name fell out of popularity. I think it's a great one. But what they did, so my grandma used to get these, the literary digests. Like there are these little like magazines about this big, and I don't even know what they talked about. I think it was mostly just trying to sell old people stuff, right? And so they sent this out though. In 36, it was probably a very different magazine than when I remember it from as a kid. But they got this bright idea, like, okay, people read a magazine. What if we can predict the election, right? And if we predict the election, then the outcome ends up being true. Like this looks good for us. Like reputation, you know, boosts, and maybe more people want to buy. So they send out these 10 million survey cards to people, and it's not necessarily people who are, you know, subscribed to their magazine. In fact, we'll talk about the process they use in just a second. But after they sent these 10 million cards out, they got 2.5 million back. I don't know what you guys have taken any upper level marketing classes. I don't know how far up you are. To get a 25% response rate to like a random survey is very good, right? Like it's hard to get people. I mean, I get emails all the time, like to win a gift card to respond to some survey, and I never do it, right? So it's very difficult to get people to respond. So like, man, this is awesome. 2.5 million people. That should be more than enough to predict the election, right? I mean, we should have more than enough people. And what they did was they predicted a landslide victory, 37 or 370 to 161 electoral votes, 57% of the popular vote. The only problem is they predicted it for Landon to win. What actually happened? The landslide went in the opposite direction, right? So their poll predicted Alf Landon was going to win by a very good margin, right? However, and Trump might dispute this, but I have to imagine this is maybe the most electoral votes ever won, at least if we skip the first few elections in the United States, right? It's almost all the electoral votes went to FDR. So how did they get this so wrong, right? Their prediction was way off, and they had 2.5 million people. It'd be one thing if they had 100 people and they just happened to get oversampled from Republicans oversampled from Republicans because Alf Landon was the Republican candidate. So then it would have been more likely they predicted he won. But they had 2.5 million people, right? So at first, I'm just going to be done with this slide. But right, what went wrong, right? Math errors. Did they treat it like a population variance instead of a sample? Well, that's not going to make that big a difference. When we're dividing by n instead of n minus one instead of n with 2.5 million people, that doesn't create that much of a gap. Now, what makes a little more sense is, well, did we somehow mail more of these survey cards to Republicans? Because if we accidentally somehow sent more of them to Republicans, even if Republicans and Democrats responded at the same rate, like let's say I sent 7.5 million Republicans and only 2.5 to Democrats. Well, then for sure I'm going to see that the Republican candidate is going to win, right? And I could break this stuff into like maybe people who are undecided, right? But if I oversampled from the Republicans, I sent more mailers to them, then my survey is really going to be skewed. It's going to be very biased. So what we would call that, and I'll go over that in a second, would be like the selection bias. I over-selected a certain subgroup in my population. Maybe Republicans were just more likely to respond. I don't know why, but maybe I sent 5 million to Republicans, 5 million to Democrats. No Democrat sent one back, and 2.5 million Republicans did. Well, that's going to skew my sample, right? Now, I use the extremes there, right? Maybe it could be somewhere in between, but that would be the idea, right? So what we would call that is there's a response bias, or typically we call it a non-response bias. One of the groups was more likely to not respond to this survey question. So we've got these two biases, and I'll talk about a couple different situations where we can think about these popping up. But for now, we'll kind of still focus on this Alf Landon, FDR kind of election. And there was a paper written, I think it's getting older now, like 15, 20 years ago. And they were able to find people who voted in the 1936 election. They're very old at the time. And then ask them more information to get an idea about, was there some type of over-selection or non-response bias? Okay. So what about the selection bias, right? So we need to make sure we have a sample that reflects the population. We weren't over-selecting from one group. Well, the problem is, Literary Digest sent these mailers out to a list of names. So they got 10 million names. How'd they get those names? They cross-referenced automobile registrations and then telephone numbers, like a telephone book. Okay. So we're in 1936, right? Who do you think has both a telephone as well as an automobile? Rich people, but also probably, I don't know, talk to your grandparents stuff. Back in 1936, to have your own telephone line, if you lived out in the middle of the country, you didn't have your own line, right? You had like shared lines, right? A lot of people, they didn't even have lines ran out there yet. And so you're probably not only talking about wealthier individuals, you're talking about people who are more likely to be urban, right? And we know that there's voting disparities between urban and rural, right? So we look at this and we're like, man, we've got these built in. Now, the one that's really kind of plays out here, it doesn't matter so much that we over-selected urban versus rural, but the income thing, right? If we look at the correlation of income to voting patterns, wealthy individuals tend to vote more Republican. Right? If I had to go out on a limb, something about keeping more of your money, right? But that is the general correlation, right? And so if I oversample wealthier individuals, then I'm actually oversampling more like people who are more likely to be Republican, right? So this process I used to get these names, right, was more likely to select Republicans. So in fact, when they found these people years later and they surveyed them and said, oh, who did you actually vote for? Kind of in 1936, did you own a car and telephone, and all these different questions? What they found was that for people who actually ended up voting for Roosevelt and actually ended up voting for Landon, right? So this was like in 1990 something. They surveyed them and said, who did you vote for? And then did you own a car and telephone at the time? What they found was that of people who owned a car and a telephone, right, or had their own telephone line, 53% of them actually ended up voting for Landon. So in terms of, if the entire population, right, was in this group, then the poll actually got this pretty close to correct. Right? I mean, I think they said 57% of the popular vote, but 53 is not that far off, right? And they at least would have had the prediction of who won correct, right? The problem is, this isn't everyone, right? It's only 27% of the entire population at the time had both a car and a telephone. 29% only had a car, about 6% had only a telephone, and 30%, 7% of people had neither, right? Well, if you think about who had neither, these are probably rural individuals who pretty low income. We look at, someone who's pushing welfare, programs at the time. Whoops, sorry. If we would have sampled the people who didn't own a car and telephone, 73% of them voted for Roosevelt, right? And so the selection of names really kind of built in this selection bias. In fact, the real interesting thing that came out of this, so this was kind of expected by at least the authors going into the study. What's really kind of odd is if you just would have used only people that had a car or only people, you didn't cross-reference this, people that belong to those groups actually didn't have this kind of bias built in, right? So, maybe you were wealthy because you had a car, but maybe you were more likely to have that car, you were more likely, and no telephone, it was more likely you were rural. And so the rural aspect, maybe more likely to maybe vote Republican, so it's kind of this combination of things, but they cross-referenced it, right? So they ended up with this really wealthy group. Right? And then you can kind of see the overall totals, right? Ended up about 60% of people ended up voting for Roosevelt, and only 7% voted for Landon. So they had a built-in selection bias, right? They were over selecting wealthier individuals who were more likely to be Republican. Okay. Is that making sense? Any questions on that? So this is the weird one, and I think this paper has an explanation. I don't know if I buy it, but I'll tell it to you once we get there. Which is that, well, did we also have a non-response bias, right? Because, we predicted 57%. From this group, really it was only 53. How do we get that additional 4%? Right? Well, they went back and surveyed these people who voted in the 1936 election, asked them if they got this mailer. They found the 10 million, or a good majority of the 10 million people, and said, did you actually return it or not? To try to figure out who were those 2.5 million people that returned it, who were the 7.5 that didn't. Well, at the time, and this was, they couldn't mimic that or go back and see who actually returned it. So they just resent another survey and then said, did they see if they responded to that one? Right? So of people who had a car and telephone in 1936, right, people who actually ended up voting for Roosevelt and people who ended up voting for Landon, about 35% of the people who voted for Landon were more likely to return the straw poll, while only 70% of people who voted for Roosevelt returned the straw poll. So, and if we kind of go down the list, it doesn't actually matter. They could have done this and not cross-reference the names. People who owned a car only, people who voted for Landon were more likely to send a survey back. People who only had a telephone, people who voted for Landon were more likely to send a survey back. And then the neither category also, even if we would have oversampled the low-income individuals, for whatever reason, the Republican voting individuals were more likely to send something back, right? More likely to send this ballot back. So it's very difficult to protect ourselves from a non-response bias like this. How am I supposed to know that in 1936, the Republican voting individuals were almost twice as likely in some situations to send back a survey card, right? Kind of hard to predict that, right? But these are things we want to be concerned about when we're looking at our sample, right? Could we have this bias built in? And I think the paper, the explanation is something like, people who are Republican because or people who want to vote Republican tend to be a little bit wealthier. Wealthier people tend to be a little more involved in the politics. They have a little more free time. If I'm worried about paying my bills and going to work, I'm just tossing the mailer out and not worrying about sending it back. I don't know. That's a bit of a stretch to me. And I'm not in the political world, but it's kind of interesting here to see that for whatever reason there was this non-response bias between the two political groups. Right? So we had both a non-response and a selection bias built in. Of course, this survey was going to predict the Republican candidate who was going to win. Right? So what else can go wrong? We'll talk about some other biases here, and not specific to that election, but people can just lie, right? If you're asking surveys, if you have a survey and you're asking for responses, I'll tell you right now, if you look at like drug use data from surveys, it doesn't match up with at all, like arrest records and things like that. That's because people are going to more likely lie to you about their drug use. I did a paper once on, it had some variables with alcohol consumption, like self-reported, and it's like, okay, these look probably a little bit lower than if we look at overall alcohol sales in these different states. People also might just non-maliciously lie if you're asking them a survey question. So think about those people they found that voted in 1936. I don't know. Maybe some of them literally, I don't know. You get old, you forget things, right? So maybe they forgot, or maybe they accidentally thought they voted for Landon and they're like, oh, I actually kind of don't remember who I voted for in that election or something, Or you ask somebody, well, how much income did you earn last year? They're probably going to give you a ballpark, right? They're probably not going to be able to tell you down to the cent what they made, right? But they'll round it up to the next 10,000, right? Maybe they made 34,136 and they're like, I made about $35,000 last year. Well, it's not completely accurate data, right? It's not that far off. They didn't maliciously lie to you, but they did non-maliciously lie, right? And if people are more likely to round up than round down, well, then your income levels are going to look like they're a little bit higher than they actually are, right? So we've got to be concerned about people lying to us. There's a lot more research recently just about subjective understanding of questions. So the way in which you phrase a question can elicit very different responses. I need to go back and maybe I'll try to bring it in Wednesday. So it was been right before the last election now, back when Trump was president. Fox News did something and they asked, basically the question was trying to get, do you think the president's doing a good job right now? But they phrased it in two very different ways. So one of them was in light of recent events, and it named these positive things, how do you think Trump is doing? And there was another question, which was something about, here's these negative things that are occurring, how do you feel the president? And there was an 8 or 9% gap kind of in it. So just the way you phrase a question can kind of lead people to certain answers, right? Or maybe they didn't understand the question, right? If it was written kind of convoluted, maybe you kind of elicit a different response there. So we'll think about this. We'll kind of look at the results here. I'll get you all recorded for being here today. We'll kind of be able to think about these biases in a slightly different context. So if I had to ask you today, how would you rate your health from 1 to 4? There's obviously no wrong answers here. So kind of using your eye clickers there, which of these would you say most best matches up with today? So rate your own health from 1 to 4. Kind of collect these responses, and we'll think about. And I'm not going to look at this, so I just I'm not going to look at individual responses here. So don't worry. So we have what 3. You gonna need one more person here?
Yeah, I forgot.
Oh, okay.
Sorry about that.
Remind me after class, I'll tell you. Okay. So let's look at the results here. So, well, I'm glad to see nobody feels like a 4 today. But right, we've got kind of the bulk of our responses there in the middle. Let's think about the biases that could exist if I ask a question like this. First of all, if I'm asking you're my sample, if I'm interested in the overall health of the population, what's probably true about the average health in this class relative to the population? I mean, just based off one characteristic, which is that you are all young, what do you think is probably true about your health relative to the population as a whole? Better, right? Now, maybe, I had, maybe some of you have some underlying health issues that we haven't oversampled from, right? But on the average, right, because of that age factor, probably shouldn't be using this sample to make statements about the population's health. What could also have been a bias that was built in here? Well, hopefully what bias did so that was my selection bias. I oversampled individuals who were younger. That's related to this variable I'm interested in, which is overall health. Right? What bias did I shut down, hopefully, by making this an IQ question? The non-response bias, right? If I gave you the option, right, this wasn't tied to points, who do you think is more likely to maybe not answer this question? Somebody in poor health as opposed to someone in good health, right? So if I'm giving people, I give them a survey and I don't create any incentive to answer every single question, maybe individuals who feel like they have poor health just don't answer this question, right? So I need to maybe tie some incentive to it, like an iPhone point or something like that, right? Or a free gift card, like my example earlier. What's another thing that could have happened here, especially if I only gave you like 10 seconds real quick to answer this? Yeah, maybe I thought 1 was really bad because it's a lower number, and I thought 4 was really good, right? So occasionally when I have bigger classes, I sometimes get like one person where I'm hoping that's the case, right? Where I see someone respond to the 4, and it's probably just someone misunderstood the question. Someone usually pipes up that, yeah, I thought I didn't even read that, right? So that's kind of that subjective component. You have to make sure you're really clear here, kind of what the numbers 1, 2, 3, 4 actually represent. What's another issue, and we didn't really talk about, so we've got non-response selection, the subjective terms. The only one we didn't talk about is kind of malicious or unmalicious line. So here, the issue, you would think that, I don't know, maybe people who are in poor health are more likely to tell you that they're in better health, right? But there's a non-malicious lie component here, which is really weird, that pops up in all self-reported health data, which is on average, people generally, like if you take self-response, like rate yourself, usually they do like 1 to 10 or something like that, your health. And then you actually look at vitals, like blood pressure measurements and things like that. People on average think they're not as healthy as they actually are, right? Maybe it's because we've become, I don't know, we're too concerned with every little thing, right? And that we generally think we're unhealthier than we are. So when you look at self-reported data here for health, it's generally an average lower. And people aren't trying to lie to you about their health. They just, for whatever reason, psychologically, we always think we're a little bit unhealthier than we are. So they're non-maliciously lying. Another one we didn't talk about, which doesn't really have a name, and it's not, it'd be a little more important if we had like this survey design class or something like that, where we're thinking about collecting data. If I only give you these 4 responses, what's the problem if I feel like I'm a 1.5 today? I'm somewhere in between these discrete categories. Well, then you literally forced me to lie to you, right? I can't tell you exactly how I feel if you didn't give me the response that would match up with how I actually feel, right? Somewhere in between the 1 and 2. So by creating these kind of discrete categories, we kind of force people to non-maliciously lie to us. So let's see if I get this going here. There we go. So I mentioned all of these, I think. Make sure. Right, I talked about this discrete option, interpretation, kind of this non-malicious lie, and then we talked about the selection and hopefully shutting down that non-response bias. Okay. So we'll do one more, and I think this one maybe has some good points, and we'll go through this one pretty quick. So on average, how many alcohol drinks do you have each week? Okay. 0, 1 to 5, 6 to 12, more than 12. Okay. Once again, I'm not looking at individual responses here. Don't worry, confidential. I think we had 11 people. Everybody got this in? All right. So once again, we might have a selection issue here. What do you think is probably true about your alcohol consumption relative to the population? Yeah, you're college students, right? We look at college students' drinking behavior. It tends to be higher. Right? Not asking about individuals here. I'm talking about the group of college-age students, right? And so if I over-select college-age students, I'm always going to see an overinflated view here if I'm trying to make inferences about the population. Okay. What's another issue that could be this? Well, the non-response bias here, even though I'm tied kind of points to it, who do you think might be more likely not to respond to this question? If I was guessing, this group, right? Right? You may be worried I'm going to look at it. Or if you think about this in the more extreme example, when we look at survey data about illicit drug use, like illegal drug use, you have like cocaine responses. Like nobody tells you that they're using cocaine. Like nobody does, right? And so like you're like, oh, no one, great, we solved the drug crisis, right? I've got a survey, no one's, but so you might be more likely to have non-response bias from this greater group. So what's that going to do to your overall sample average relative to the population? It's going to skew it which way? To the left, lower, right? Because your higher numbers are more likely not to respond to you. Which of these might I see more responses of if people are maybe maliciously lying to me? 0, right? Maybe you're worried about me looking at these after class, and so maybe I see a lot more zeros here. I'm afraid to pull up what the actual responses were here, but we're just kind of getting an idea. Let's do it just for the sake of being fun. Okay. So you guys aren't too bad, or you're maliciously lying. One of the two. Right, that's the idea. Okay. So I'll tell you what. When I was, well, I shouldn't say what my answer would be when I was in college, but here we are. So the other thing we can kind of think about, we've got that selection, non-response bias. We might have people maliciously lying. Also, maybe non-malicious lying, right? Tell me between 6 and 12 or more than 12. I don't know. Maybe I'm on the cusp. I don't really keep track of how much every single drink that I have on the weekend or something. So maybe I just non-malicious lie. I accidentally tell you a category I'm in when I was actually supposed to be in the one above or the one below it, right? So we're designing these survey questions. It gets a lot trickier. I'm glad that I don't design surveys. I just look at the responses and then kind of think about the bias that might exist because of the way that people wrote questions. So we'll use this idea of bias. I got one more example, and I'll probably put this, I think there's 2 papers, but one specifically I'll put up on Canvas just in case you're interested because it's pretty interesting. And I'm not like the biggest political junkie, but the political side of things that interests me is kind of like whatever they're trying to make these predictions for the elections and then see how wrong they usually get it. So if you go back to the 2016 election, there was one poll that predicted that Trump was going to win the election out of hundreds, right? I think was it Reuters was the one that predicted it correctly, but everybody else got it very wrong, right? Well, how are they doing? I mean, they were taking random samples. They were using stratified cluster sampling, right? How did they get this so wrong? So we'll think about some of the biases that might exist. We went back to that 2016 election, okay? So why did they all get it wrong? Was there a selection bias? Were they over-selecting from certain groups? There's an argument to be made, this paper has, that maybe they were, right? And so I was maybe over-selecting from the group who was more likely to vote Democrat, which is that a lot of these large polling centers, if you're relying on things like door-to-door surveys, or you're relying on like phone calls, there are a lot more of them in larger urban areas, which tend to vote a little bit more to the left, right? And so maybe that was influencing a little bit. Now, the paper doesn't argue that this was a strong bias, but it would push it in the direction to be more likely to think the Democratic candidate's going to win. The other ones that are really interesting, and I think the selection bias is usually something we can shut down. If I was a really good polling agency, I don't rely on just the people around me, right? I'd be randomly calling people all over the nation, right? And there are plenty of polls that did not fall victim to selection bias. But how'd they get it wrong too, right? So the other one, they have, which is kind of interesting, and generally education, I mean, it's not a one-to-one or the strongest correlation, but people that have higher educations tend to kind of be on the left side of things more than in the right. And one issue that has come up in some of the political studies is that more educated people are more likely to be involved in politics. So they're then more likely to kind of respond. So it's not so much that it's kind of a combination of non-response selection bias because more educated people are more likely to kind of respond to these different phone calls and things like that. It's not like you were calling more Republicans than Democrats, but you may end up with people being kind of more educated, being a little bit more likely to be involved in politics, kind of once again, kind of pushing your sampling bias towards the left. Okay? Now, the bias of this paper really gets at, and this is, I think, at least my memory of the 2016 election really, really hammers home. Right? So it's this idea of a non-response bias. Right? So if I'm sending out if I'm calling people or sending out mailers, who is probably more or less likely to respond, right? People who plan to vote for Trump or people who plan to vote for Clinton? You had to guess. Who is more likely to not respond? Why?
I feel like there's kind of like a stigma for him.
Yeah, right. So this paper gets at, and there was like this social stigma, right, at the time. And so if you're doing any type of personal phone calls or in-person surveys, it was really way more likely that a Trump voter wasn't going to respond, just hang up the phone, or wasn't going to accurately tell you who they were going to vote for, right? Might tell you they're undecided. Maybe they don't tell you they're going to vote for Clinton, but they told you they weren't decided, right? So we kind of have this non-response bias built in. And like I said, I believe the paper gets at that they found this was greater with phone surveys relative to like mailers, right? When there was this personal interaction, this social cost really influenced people's responses. So they called these, where was that? The malicious line, right? The people who actually did respond, even if we, so they imagine there's this non-response bias that people were just less likely to, they're more likely to hang the phone up, right? But even the people that stayed on the line, it was more likely that they maliciously lied, right? They just told you they were going to be undecided, even though in their heart of hearts they knew they're going to vote for Trump in the upcoming election, right? Non-malicious lying might be some of these people who actually were undecided, right? I've changed my mind across the whole year about maybe I'm voting for this candidate, maybe I'm voting for the other because I don't like either of them. So I keep going back and forth, right? So there were some people like that, but this paper makes the argument that this non-response bias of Trump voters, as well as kind of what they call the shy Trump voters who maliciously lied about who they're going to vote for, really skewed these polls. And it really made this point, which is, if you've got something that has a social cost to it, like you need to really make sure that you shut that down. Otherwise, it's going to greatly influence your results. Yeah.
How do you think this bias changed from the 2016 election to the 2020 election?
Probably not a ton. Although I would argue, this bias probably existed. What I would say is, because a lot of the polls still didn't really match. There was a lot that thought it was going to be even further of a gap than it actually was. So even though the Democratic candidate won, the majority of the polls was over predicting. And I also know that a couple of the polls even mentioned that they tried to account for this factor. So they didn't they report the actual results, but then what they expected kind of the built-in bias to be. But yeah, I wouldn't necessarily expect it to change a lot. Although
I was just saying
the social cost could have changed, right? It's really hard to measure the social cost. So if in the 2020 election you believed it was less of a social cost to say that you're supporting Trump, then you would expect these biases to go away.
I guess I just found it interesting because to me, I feel like Trump voters have always been the more vocal about their support.
Yeah, so I think about it this way. You're right. It's hard to think about. This is a little bit different than the example we talked about. So with political polling, you've really got three groups that you're interested in. Your extreme left, your extreme right, and then the majority of people in the middle. I don't know the exact numbers. The way I envision America, it looks something like this, right? And so for sure, the people on either side may be very vocal. They're not going to be afraid to respond. They're not going to maliciously lie to you. But those are also the people that you don't have to worry about how they're going to vote, right? The people you're worried about how they're going to vote is everybody in the middle. So it never fall victim to these biases. The only way this bias is showing up, this non-response bias, is from these people in the middle. That even if I'm leaning a little bit more to the right, I know that Trump really rubs people the wrong way, and I might not want to respond to someone I don't know that I'm telling them to vote for Trump. But you're thinking, you're right. Some of these groups within the entire population probably won't fall victim to this bias. Does that make sense?
I'm just having trouble visualizing.
Yeah.
Especially because for our age, social media is the most dominant platform where political things are.
Yeah, and so this is another interesting thing that this paper talks about is that difference between the in-person surveys and their mailer surveys, that the mailer surveys were more accurate, and this idea that just this personal interaction on a phone call, there was a social cost to not being as likely to either respond or admit who I was going to vote for. But it's very easy if there's not somebody on the other end, right? So if I'm posting something on social media, or you know, they kind of make the point that I think it was Reuters that got it right, really heavily relies on only online polling. Online polling, there's nobody on the other end. You can shut down that social cost a little bit more than if you're using phone banks. So that's kind of the idea there is, as we look at these political polls that are doing a better job of predicting, they're kind of moving towards like using social media platforms to gather this data, as opposed to the old school way, which is like phone banks and like going to, you know, door to door, sending out mailers. Yeah. All right. So next class, we'll start talking about, once we have this sample, how can we think about the distribution of these sample means that we'll see? Okay. So I will see you guys on Wednesday.